When looking at drag struts and shear walls, a really good idea is to totally eliminate the walls that are perpendicular to the load. That will help you understand the mechanics. So in this example, we have four walls, one on the north, one on the south, one on the east and the west. And suppose the earthquake is hitting the building in this direction, in the north-south direction. Who disappears? Who disappears? The answer is south disappears and north disappears. They are gone. They are not there. This will help you. This element in here, the purple one, is the drag strut. And you could see that it goes from under the diaphragm but above the shear wall. This is the drag strut. Now, if the earthquake is going in this direction, is this in tension or compression, this element right here? And think about it this way. This point does not move, and the diaphragm is being drawn in that direction. So this has to be in tension. Less tension, less tension, less tension. Zero out here because there's nothing out here. Take a free body and there's nothing on the right side of that point. If the earthquake is going in the other direction, the opposite is true. Here we have nothing, of course, and then but this diaphragm is being drawn in the other direction. So here we have compression, 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 more compression, more compression. Now, if the earthquake is going in the other direction, we have the same ideas here. So let me show you this. So here we have an earthquake going in this direction now. So who disappears? The ones perpendicular to the load disappear. So they go away. And we only have these two. Now, if the earthquake is going here, this drag strut is under the diaphragm. And you could see it here. And the diaphragm is moving in this direction. So is this diaphragm in tension or compression? And the answer is tension. Tension, less tension, less tension, less tension. No tension right here because this is air. And then if the earthquake goes in the other direction, we have a similar situation, but now this diaphragm is moving in that direction. So we have compression, we have zero, sorry, compression, 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 and then you will calculate that, okay? And then, of course, the diaphragm is fixed between these two rigid shear walls. So in this example, this becomes a chord. And that, in this example, would be tension or compression. The answer is compression. And then this one would be in, well, if the diaphragm, if it's going this way, if the earthquake is going this way, then this chord would be in tension. Okay.